Today we are going to look at methods of generating Pythagorean triples, and here we consider two numbers x and y where x is greater than y, and we have x squared minus y squared, we have 2xy, and we have x squared plus y squared. And it is quite easy to show that if you square this and add the square of this, you will obtain the square of this. And so if we take the two smallest numbers we can, 2 and 1, if x equals 2 and y equals 1, then we have 2 squared minus 1 squared, 2 times 2 times 1, and 2 squared plus 1 squared, and this of course is 3, that is 4, and that is 5, and we have our old friend the Egyptian triangle. And then if we multiply these numbers by 2, we obtain another Pythagorean triple, and multiply by 3, and we obtain another one, except that this is different, because 15 cannot be expressed as the sum of two squares. And so this method seems to have a limitation, which another method seems not to have. So we're now going to examine this other method. In this other method, the number 2ab is any even square. So I can use 2 times 1 times 2, which is 4, that's an even square. And I consider the three numbers a plus root 2ab, b plus root 2ab, and a plus b plus root 2ab. I should say, by the way, that I found this method in George Gamov's book 1, 2, 3, Infinity. And by algebra, it is possible to show that this squared plus this squared does indeed equal that squared. And unlike the previous method, it seems that this one will generate all Pythagorean triples. If I take my first example, 2 times 1 times 2 equals 4, the square root of 4 is 2. I can do 1 plus 2, I can do 2 plus 2, and I can do 1 plus 2 plus 2, and that gets me 3. And 4 and 5, and once again I have our old friend the Egyptian triangle. If I now consider this case, 9, 12, 15, which the first method doesn't generate, I can in actual fact show that my method, this new method, the Gamow method, will generate it. So the three numbers in this triple could be a plus root 2ab is 9, b plus root 2ab is 12, and a plus b plus root 2ab equals 15. So that if I do 15 minus 12, that is a plus b plus root 2ab minus root 2ab, minus root 2ab minus b, that will be a, and that will be 3. And if I then do 15 minus 9, I get a plus b plus root 2ab minus root 2ab minus a, and that is b, which is 6. So that 2 times a times b will be 2 times 3 times 6, which is 36. And so I can show that it fits the pattern. So if I fit those numbers in where they go there, I find that my first one is, of course, going to be 9. My second one is going to be 12, and my third one is going to be 15. And we know that this result is true, so that 2AB was 2 times 3 times 6, which is 36, which is 6 squared. But what I don't know is why this method produces 9, 12 and 15 directly, but why the other one doesn't. And if anybody's got any ideas about that, I'd be interested to hear from them.